Great. So it's 3 p.m. here in France, in Toulouse. And we're going to start this webinar about the Master of Science in Aerospace Engineering with a specific topic this year, today, for students with specific backgrounds. So I'm Justine. I am admission advisor for the Master of Science at ISAE-SUPAERO. And today we have the pleasure to have 3 professors with us who will present us their major. So I'm going to share my screen. Okay, you can see the screen. And this is what we're going to talk about today. So first of all, I'm going to introduce you the school for the one who don't know yet what is Aerospace. Very short introduction about the Master of Science in Aerospace Engineering, just to let space for our 3 professors to introduce you the 3 majors. So the first major so there are 7 majors in the Master of Science. Today we can present 3. We're going to present Embedded System with Professor Alem Mifdawi, the major Space Imaging, Navigation and Communication with Professor Rock, Damian Rock, and the third major, Aerospace Systems and Control with Professor Valérie Budinger. And finally, admission process, tell you how it works, etc. The deadline, which is in 7 days now, and a Q&A. The point of this webinar is for you to ask your questions. So really don't hesitate. All right, I hope you can all hear me. And if you have any doubt, any question, use the Q&A box for all questions about the webinar and about the sound or screen discussion box. All right, so ISAE-SUPAERO is well known as a world leader, one of the world leaders in aerospace engineering higher education. The motto is excellence with passion. It was founded more than 100 years ago by ambitious, passionate scientists. And ISAE-SUPAERO's mission today is to contribute to the development of the aerospace sector. So ISAE-SUPAERO trains high-level engineers, aerospace engineers, and their mission will be to meet all the innovative and sustainable challenges of the air transport of tomorrow. So big challenges for future engineers here. So the location is in Toulouse. Toulouse is the capital of aerospace in Europe. And it's the heart of the French aerospace valley. So we are surrounded by a lot of aerospace companies, which I'm going to introduce a bit later. And ISAE-SUPAERO also have different programs. Today we talk about the Master of Science in Aerospace Engineering. But there's other programs that you can check later online. So where are we? Toulouse, it's in the south of France. It's close to the border of Spain. You see here a more detailed map of Toulouse. ISAE-SUPAERO is in the south of Toulouse here. And you see that all around you have all those aerospace companies that are playing an important role for the development of the aerospace sector here in the region and in the world in general. So all this gives a lot of opportunities for our students to find the first job, to start their career, but also for the university, for us as a school, to receive from the industry, to know what they need as a training to meet their industrial needs, and so that our students can adapt to the industrial needs. So ISAE-SUPAERO have many partners among those companies. There are 17 partners that you see here on the screen. So Airbus is one of the biggest here in Toulouse. Also Thales, Ion Group, Safran, Accenture, MBDA, a lot of famous names in the aerospace sector who plays an important role for the school, for ISAE-SUPAERO. First of all, for us to adapt a program according to the industrial needs. They also share with us their employment needs. They share with us all their internship availabilities or employment availability. So it's very an asset for our students. And we also received some of those professionals to teach here at ISAE-SUPAERO. And finally, some of them participate in the scholarships program I'm going to talk about a bit later. These are some alumni, famous alumni from ISAE-SUPAERO, men and women engineer who passed by ISAE-SUPAERO, who have or had a high position in the aerospace industry. So you have, for example, Marcel Dessau, who was the founder of Dassault Aviation. Here you have Elodie Viau, who worked in the European Space Agency, Director of Telecommunications. Also a famous astronaut, Thomas Pesquet, French astronaut. So Guillaume Faury, CEO of Airbus. So famous names that we are proud to say passed by ISAE-SUPAERO. All right, I hope you follow me so far. Now we're going to enter in detail about the Master of Science in Aerospace Engineering. So it's a 2-year program, fully taught in English. So we welcome students really from all over the world. It's divided in 4 semesters. The first one focusing on common cores. So it's science and engineering main topics, project management, foreign languages. It's also the moment, the first semester, where students receive a lot of information about all their possibilities to continue for the next 3 semesters. This is when they were going to choose the 4 electives during the second semester. They're going to also choose their research projects and choose their major. So the first semester is a moment when they learn from the professors, from their peers, from other students, from their teachers about all the possibilities to make their own way, their own curriculum during those 2 years. So during the second year, the third semester, they have 1 out of 7 majors to select. So I'm going to explain the 7 majors later. And then the 4th semester is an internship in a company or in a laboratory, 6 months internship. 7 majors. So first one being, there are 7. We're going to present 3 today. They are advanced aerodynamic and propulsion, aerospace structures, aerospace systems and control, embedded systems, space systems, systems engineering, and space imaging, navigation, and communication. So the one in bold here are the one we're going to present to you today. So as I told you, the program is fully taught in English. So students don't need to speak French before coming to ISAE-SUPAERO. They're going to have French class included in the curriculum. ISAE-SUPAERO also have a career center, which is very helpful for students when they have to access their first internship, first employment in France or in Europe. Sometimes culture is different, so we help them to adapt. We help them to make their CV, their cover letter, to have an interview. They also organize job datings or company visits so that we make students meet with the professionals the most possible and create their contacts. And they also share all those internship and job lists that the partners send to us. So it's very an asset for students, and they use it a lot to start their career. And finally, strong engagement of ISAE-SUPAERO into the ecological transition. It's very important nowadays, as you know, that we adapt all our curriculum according to the green industrial needs nowadays, mostly concerning the decarbonized aviation. So we try to adapt all the courses according to these challenges, ecological transition. Okay, now I'm gonna give the talk to our professors. So we're gonna start with Alem Mivdawi with the embedded system major. So Alem is a full professor here at ISAE-SUPAERO, and she's the head of program of the major embedded system. So hi Alem, you can maybe share your screen.
Thank you.
I'm going to stop mine. There we go.
Okay, hello all. Before starting, maybe we'll try to explain a little bit what is an embedded system, since I think it's a new keyword for those who don't have really electrical engineering background. So here is an example of an aircraft, and as you can see in an aircraft, there is a lot of computers to do a lot of things like flight control, cabin management, passenger information, and many other functionalities. And all these computers are connected with a network.
Excuse me, Alan, we don't see the slides passing.
Oh,
like we did before, maybe do
okay.
it again.
Now, is it better? Okay, maybe
Yes, now we see.
Right. Okay. So yeah, here is the famous picture. So what is really the difference in comparison to an open world computers? So here, of course, we have to handle extra constraints like energy efficiency, safety, certification requirements. And during this major, you are going to learn how to handle all these constraints. So nowadays, there is many innovations in the field of embedded system that have a great impact on embedded system domain. At the hardware level, we talk about many core architecture. I'm sure that you have already heard about IoT, cloud computing, big data, machine learning, cybersecurity. So all these new technologies have really revolutionized the embedded system field. So nowadays we talk about new applications domain with smart keywords. So smart mobility with autonomous vehicles, smart factory in automation, smart cities, which really touch our everyday life, and of course, smart healthcare. So these all new domains have led to a great growth of embedded system market. So as we can see in the last 6 years, we have almost 50% of the growth, and consequently endless job offers for our students. Okay, so our objectives in this major is really to give you the basics to be able to understand the industrial needs and to convert them to technical specification, to design the system which really fulfills their needs. Of course, to be able to implement such system, to validate them, and to go even through the certification procedure. So our methodology for during this major is really to focus more in practice, more than theory. This approach will really enable innovation. We emphasize a lot on the new technologies. So this is very important for us to be sure that you will be up to date when you go to industry during your internship, but also when you will be hired. We cooperate a lot with industry, and this is through lessons that are given by industrial partners, but also using realistic industrial test beds. So in the first year, we have around 230 hours related to embedded system, plus a research project. I'm going to come back on this a little bit later. So during the first year, in the common core, there is mainly three models that are related to embedded system major: algorithm and computing, introduction to embedded systems, and introduction to system engineering. So during the first year, we will try to build a first background for those who don't have electrical engineering background by learning how to program, how to simulate the system, how to understand what is a network, what is a system, and also new technologies like cloud computing. So in the second year, the major is around 230 hours. And again, here we will try to build the basics at the beginning. So we have around 135 hours to give you the opportunity to understand what is a system from the software level as well as the hardware level, to be able to program such systems and to handle the real-time features from the system point of view, but also the communication point of view. Afterwards, you will have, of course, basics to be able to design such system. So we talk about model-based system engineering. You will also apply IA for autonomous systems, and also understand the different constraints for the system, like dependability and certification. So during the different lectures, we have a lot of hands-on experiments, like machine-to-machine, cloud computing, UAV, autonomous robots. So again, we insist a lot on practice because we think that it's the best way to learn. Okay, so here are some examples of research projects. I'm not going through all the details, but as you can see, we cover a lot of domain applications like UAV, autonomous vehicles, avionics, and of course, space. In each domain, the professors try to give subjects to focus on new technologies, like, for example, blockchain, cybersecurity, IA, of course, and many other concepts. So after the theoretical semester, what you can really do in industry, of course, you start with an internship. So here are some examples of master thesis for this year. So you can, of course, work on small company like startup. This year I have 2 students working on EasyMile, which is a startup in Toulouse working on autonomous systems. You can, of course, work in big company like S2C, Airbus, Continental, and many others. I have also some students working on research labs like CNES, Onera, LAS. So you have really a lot of possibilities after the first semester. And here, just to recap a little bit, our main partners which propose internship and of course job offers, but it's not a complete list. Thank you for listening.
Thank you so much, Alem. I guess we'll have some questions, but maybe we'll tackle them at the end.
Let me stop sharing my screen.
Thank you. Okay, so I continue. I share back my screen with my mouse here. Okay, and we're going to welcome Damian Rock, who is head of major space imaging, navigation, and communication, and full professor at ISAE-SUPAERO.
Okay, hi everyone. So yes, I'm going to talk about the major space imaging, navigation, and communications. So in short, SYNC. So let's go for the next slide. Okay, so I'm going to start by the teaching program. And before we dive into those details, let me first emphasize the focus of this major. So in SYNC, we are interested in the satellite payloads and terminal design. It means it implies image sensors, communication systems, and in particular space communication systems. You all know that there are many mega constellation projects in the so-called new space trend. Okay, so we are part of it. As a prerequisite, we rely on basic mathematical background and in physical background as well. including some linear algebra, probability theory and statistics, but also spectral analysis, things like this. Our SYNC program is achievable by aerospace and mechanical oriented students. Okay, so we try to stay focused on space applications, even if we talk about more fundamental aspects. Okay, so let me describe here the teaching program. So we start by some fundamentals in electrical engineering, so it may be somehow redundant with respect to what you have done before. We especially develop some concepts around antenna and microwave propagation. We establish also some random signal processing tools, including estimation and characterization of random processes. And then just right after this fundamentals of electrical engineering unit, we move on to more applied units. For example, the Earth observation is based on a first description of how those image sensor work. Okay, those onboard image sensor, for example, passive cameras, multispectral imaging, synthetic aperture radar, LiDAR, and so on. And then we investigate the image processing part and the data analysis. So it's more about classification, neural network based decision based on space imaging. Okay. And lastly, we focus on satellite communications and navigation unit. And here we review the basics of digital communications. So it's connected, of course, with the random signal processing unit. And we also investigate the satellite-based navigation, also known as GNSS, for global navigation satellite services. And lastly, we also give a small introduction, a quick introduction to the computer network part, okay, because the system we are developing are connected to applicative services. And it's good to have a brief outline of how those network protocols work, okay? As you can see with the color code here, there is a good mix between signal processing, applied physics and electronics, computer networks, and possibly other aspects, other scientific fields. Okay, so we can move on to the next slide. Since our major heavily relies on the so-called electronics, optronics, and signal processing department, we are using various equipments from this research lab, including the so-called clean rooms, and the first image here, where you can characterize electronic components, and in particular optronics systems. We may also we have also some platforms to integrate nanosatellites, as depicted by the second picture. We develop navigation satellite systems and custom software to perform multi-constellation GNSS receivers. And lastly, we have also an anechoic chamber to measure the antennas radiation patterns. So it's quite useful equipment to design real antennas matched to very specific applications such as CubeSats and so on. We can move on to the next slide. So here I wanted to give you several examples of research projects that are connected to the SYNC major Of course, it will imply, for example, as you can see, the first item is on 3D printed antennas. So in connection with the anechoic chamber you just saw in the previous slide. We have also laser link systems between satellite, in particular to connect LEO satellites to geostationary satellites, or even to provide high throughput feeder links for next generation satellites. We have also ongoing research on space exploration and, for example, seismic data processing in connection with Mars space missions, okay, such as I forgot the name of this Mars mission because it's not really my area of expertise. Sorry, guys. Next, we have also GNSS advanced techniques, including not only GNSS sensors, but also computer vision based sensors. And lastly, we may also investigate the design of new routing protocols within satellite constellations. So those are examples of research projects, and beyond those research projects, how students successfully find jobs in the industry. Okay, so here is an example of several positions actually held by former SYNC students. So most of them are working in the field of space systems, and they clearly they are clearly rewarded for their dual skill between aerospace systems and electrical engineering, let's say, tools or payloads. Okay, so they are working in the industry or in national or European space agencies mostly, and they are, as far as I know, quite successful in their job. Great. Okay, thank you for listening, and don't hesitate to ask a question.
Thank you very much, Damian, for this presentation. And the third major we're going to present today is Aerospace Systems and Control with Professor Valérie Bédinger, who is full professor also at ISAE-SUPAERO and head of program, the major Aerospace Systems and Control. You can go, Valérie.
Thank you, Justine, and welcome to everyone. So yes, I want to present you the major Aerospace System and Control. So maybe you can change the slide, Justine. Yes. So first, I want to explain you what is the objective of this major. And this major wants to train engineers in line with the needs of industry that will develop the aerospace system and product of tomorrow. So first, I propose you to have a look to the current developments in aerospace engineering. And you can have a look to the picture on the slide, and you see large projects. We see large projects in different sectors, such as on-demand mobility and newborn and urban logistics. So this concerns here the transport of people and objects in a more flexible way. For example, between two small towns or close to airport. And to give you some figures, in France, there are currently more than 100 projects of new aircraft for on-demand mobility. We can also observe a large number of projects in sustainable aviation, and I think you all know the challenge, which is to develop aircraft based on cleaner energy. And also, there is another challenge, which is to work on aircraft operation and airport facilities, which goes with this new kind of aircraft. We also observe challenges and projects in the space domain. So, for example, we have what we call new space in general, which concerns new uses of space and new requests. For example, in orbit servicing, for example, building platform in space and not on ground and launching there, debris mitigation, humans, but also humans in space and also other application. And finally, you also have a lot of projects on all electric platform, space platform, or electric satellites. And in a few years, 25% of satellites will be all electric. And so this implies working on new electric architectures. So next slide, please, Justine. So in the aircraft aerospace system and control major, what will you do and what will this major bring you? So our objective in this major, you will be trained to the design of innovative, non-propulsive and propulsive system, and also to the synthesis of control laws to push the limits of system. So objective is to design a system more stable, a new system, more stable, more accurate, more robust to uncertainties and to perturbation. Our second objective is to give you the opportunity to join teams working on future aviation and new space, and through the fields of system design and control. So maybe a field which is not the mechanical link to the mechanical domain or aerodynamic model, but there are many works in the field of system and control that you can, where you will be able to apply with the trainings that we are presenting to you today. For this major, the main prerequisites are mathematics, because you will need mathematics for the synthesis of advanced control laws. And we also request for physics skills to understand for the development of new systems. And new systems are multidisciplinary, so we want people that understand mechanics, electricity, and more to understand what's the design and what's the control. So we can have a look now to the program, please, Justine, with the next slide. So I do not enter too much in the detail, but what I want you to remind is that we have two main blocks. One block with modules on aerospace system. And here in these modules, we will analyze the operation and how we can model the system with objective to design new system. For example, we will see methods based on scaling law and surrogate models for the sizing of the system. Then we have a second blocks, second series of modules based on control. And in these modules, you will learn how to synthesize control laws for different kinds of systems. And so it means that you will learn how to control multi-input, multi-output system, but also uncertain system. Uncertain means that there are characteristics changing during the operation. We will also talk about the control of nonlinear system, hybrid system, flexible systems. There are plenty of systems and which require different kinds of law, and you will be trained to the synthesis of these different laws. To give you some example of practical master thesis and jobs that our former student applied. We have here the list of the master thesis in 2021. So what you can observe is that you have a large variety of subjects from company in which the master thesis have been carried out. So in France, but also abroad. So in Germany, for example, Bauhaus in the US, at NASA and at ESA, ESTEC, so this is in the Netherlands, and also in France, with at Airbus, a large company, Airbus, Liebherr, but also smaller company which are developing a new aircraft. As I've told you, there are 100 projects in this field, so flying whales, for example, Aura Aero, and so on. And also research lab like ONER. If you have a look to the jobs, so here you have the positions of former students in the last 2 years. What you can observe is that there is many jobs on control engineer, also for design, and many of the students have been recruited right after the graduation. That's very important that you understand that there are many opportunities in this domain, and also the domains of my colleagues which are here today. And at last, I want to mention that the high-level training that we propose you allows students to continue towards doctoral studies if they want to go on in this doctoral studies. So currently, we have 4 students at the French-German Research Institute, ACNES, and in ISAE-SUPAERO. And I will be glad to answer with your questions if you have any after the presentation, last presentation of Justin.
Thank you. Thank you very much, Valerie. All those presentations were very interesting and inspiring, I'm sure, for all our students who are watching us today. Now, let's talk a little bit more about, in details, how to apply to the Master of Science, and how everything works for scholarships as well. So as we told you, there are different backgrounds that we accept in the Master of Science, okay? Students here in the Master of Science have backgrounds in aerospace engineering, mechanical engineering, but also electronics, electrical systems, telecommunication, computer science, physics, math. This is also possible. This is the message we want to give all of you today, that there is different way to access the Master of Science, and there are so many fields you can apply your skills that it's important to you. If you are not sure, don't hesitate to send us an email with your CV, and we can help you tell you if you are eligible or not for the Master of Science, okay? A second important information is when to apply. So the application started in October for next September 2022. And there is different admission phase. You may have seen on our admission page. The first admission committee for September 2022 will be in January. If you want to be part of this committee, to have your application reviewed during January committee, you have to apply before the 1st of December. And also before that deadline, you will be eligible for scholarships, depending on your nationality. But it's important to apply before the 1st of December if you want to apply for scholarships. And then if you apply after the 1st of December, it's still possible till spring. You can apply till spring. But of course, the later you apply, the less spots there will be available in the master. So we highly suggest to apply the sooner, the better. And finally, about the scholarships. So there is 7 more days to apply. There are 5 provided by our partners or by the school. There is a scholarship called MBDA. It's for Indians and Indonesians. It provides full tuition fees plus part of living expenses. They all provide tuition fees plus part of living expenses. There's also the Foundation ISAE-SUPAERO. This is for all nationalities. Toulouse Graduate School of Aerospace Engineering. It's mostly for students who want to pursue with a PhD after the master program. The Airbus Chair for Eco-Design of Aircraft is for students focusing on majors in aeronautics. And finally, ISAE-SUPAERO provide a scholarship also this year for all nationality, providing tuition fees and part of living expenses. So before the 1st of December, if you want to apply to ISAE-SUPAERO scholarship, and make sure also you check with Campus France, who also offer different kind of scholarship related to your country of origin. And I will finish shortly. I will not develop too much about the campus standard facilities, because you saw a little bit of some in the presentation of our professors today. But one important thing I want to tell you is about the Toolbox process, which is very useful for our international students when they arrive at ISAE-SUPAERO. It really, I think, and they all testify it, that it's really helpful when you don't speak French, you arrive from 10-hour flight to Toulouse, you're tired. That Toolbox is really helpful. Like, they book in advance your accommodation. They help you to open a bank account. They help you with all the administrative tasks you must do at your arrival in France, in a foreign country. So this is a service offered to all our students who come in the Master of Science at ISAE-SUPAERO. And on campus, you have several student residents. So it's very convenient for our students to book their housing and go to class right on the campus, live on campus. Okay, now it's time for questions. I think we are in the timing. We have about 20 more minutes to listen to you, maybe not listen, but read you and answer your questions. So I think maybe Philip is with us.
Yes, yes, I'm here.
Hi, Philip.
Hi, everybody.
Did you try to answer some questions already, or can we answer some question in direct?
Yeah, I already answered some question. Mainly question are about the admission process and scholarships and anything. So you, the information you just gave to everybody maybe answered many questions. I have a question regarding the toolbox.
Okay.
And what kind of services are included in this package?
Well, as I just told you, they help you to book your student house, student room before you arrive at ISAE-SUPAERO. They help you to open a bank account. You also have your transport card already prepared at your arrival. They help you to open there is small help for all students who study in France, which is called CAF. It's to have some cash back on your housing allowance. So they help you to open this account also to beneficiate from this service. They help you with all the main administrative tasks you must encounter when you arrive in France.
Okay, thank you, Justine. I'm trying to read.
Okay, yeah, me too.
We don't have so much question regarding major. We just had here, and or the contents, the curriculum, and the master contents. We have mainly question regarding the admission process. Question regarding
are there going to be presentation about the other majors? We can also do some webinars about other majors, but this is a first time we introduced some majors as a webinar today. So I hope you use that time to have the professor in front of you to ask them some questions.
We have an interesting question regarding jobs after graduation in France for a non-European citizen. Maybe some professors can answer that regarding what they know about their students, their alumni right now. Is it hard for non-European citizens, students, to get job in France after the master degree?
No, it's not hard.
Thank you, Valérie.
So it's very clear and very easy because yes, they found job in Airbus, in large company, and also in smaller company. in France or in Europe, in Germany, in England. So no, it's not difficult. It seems that it's not a problem.
Good.
And
Yeah,
I think I have on my last slide, you have the different positions of alumni, and you see that many of them are non-European, and it's not difficult. It's not a problem for them to find a job because well, they speak. In most company, jobs are in English, and also French company do not hesitate to hire foreign students, and also because we need many engineers in this field, and I think there are not enough French engineers, so they do not hesitate to hire foreign engineers.
And also Toulouse is a very international city. There is students and employees, workers from all different nationalities working here. All those companies attract people really from the whole world.
Another interesting question for you, professors. It's related to the background of physics. And the question is, can I apply for one of your major if I come from a physics background? So it's very interesting to maybe to give some detail or explanation regarding this specific background in your specific majors.
Okay, yes, I can answer this one because I had the case 2 years ago. Student coming from bachelor in physics, bachelor of science in physics, and clearly yes, and he thrived in our master in the sync major, and now he works at the DLR in Germany, and he studies I'm not sure of the translation, but the relativistic effects incurred by the propagation of a wave from a satellite to the ground in view of timing estimation for GNSS applications. Okay, so yes, indeed, it's possible, and it may be quite relevant in the scope of our majors. I don't know if my colleagues would like to add something.
I have also a case last year with a student with a physics background, and he did really, I mean, great. He succeeds the theoretical semester. He did a great internship, and now he's working at ISAE-SUPAERO on autonomous vehicles. So I think that we really build, I mean, maybe I can talk about the embedded system major, but I guess it's the same for all the major related to electrical engineering. We know that you come with mainly aerospace background. So we try really to give you all the basics to master the domain that you select. In particular, in my case, embedded system, and to give you really the opportunity to change if you want the domain. So go from physics to embedded system, or from also mechanical to embedded system. I have also these examples. So yeah, don't worry about the background.
And we have a question here. I'm also a physics license in Paul Sabatier, the school nearby. We have a lot of students having a physics bachelor or license, and they are accepted as well as other students. Like it's you have a bachelor in physics, you're welcome to apply for the program, and what about accessible to different majors when you have a bachelor in physics? Is it professors? How is it? Can they apply to any majors?
In my case, yes.
Yeah.
No, the question is, can they apply to mechanics major and structure and it's difficult for us to answer because we are not in this major. Strictly on the paper, there is no restriction.
No.
But after, what happens is you have a first semester with a common core. And I think that after this first semester, the students, they see what they want to do and where they have the best chance to be the best. What is important is to be good in what you do. And so you will see what
you want to do
and where you feel like also working. But there is no restrictions strictly. We don't, for the major, we don't look at your previous background. We look to your results when you arrive at ISAE-SUPAERO.
Yeah, really the first semester is really important in the Master of Science program, because this is when you're going to have the presentation of all majors. You're going to listen to your peers with their experience. You're going to see all the research projects done. You're going to listen also to professionals talking to you. And
this is also the semester where you're going to start building your future. And we have some students with a major in mechanics, with a bachelor in mechanics and structure. And for example, they come to see us in the control major because they want to extend to get different skills than what they have before coming. And so that's the opportunity also to do something different. So we are open to people who wants to learn different fields.
Yeah. There are a question. As the Institute website lists CNES, DLR, and Airbus as potential recruiters, I would like to know if they accept non-European citizens as a.
Yes, last year I think the student who went to Airbus, it's a question of choice. It was a non-European student.
Yeah.
Among the.
Yeah, there are many.
I think the only restriction from my experience, it's when you work on defense project.
Yes.
When it's military, indeed, I think that there are some restrictions for non-European, but apart that, I think it's not really an obstacle.
No.
And I'd like maybe, I fully agree with Halem here, and I'd like to add something, because you maybe are familiar with the so-called new space trend. It implies that there are more and more private actors in the field of space systems and space services. So it's again an opportunity to maybe decorrelate the military space program and the civilian commercial program. So it generates many opportunities in small companies in particular to work regardless of your citizenship.
Absolutely. Thank you. There are some questions about if students can have the time to have a part-time job when they study. To be honest, the curriculum is quite dense during the 2 years. We don't suggest students to work part-time because they need to focus on their study and to succeed in their studies. However, you must know that during summer, students can do a 2 months internship, which can be also paid, or they can work on this time as well. And in France, the 6 months final internship is usually paid as well. As an engineer, you can expect a good minimum salary, which is very helpful, I guess, for students.
It's compulsory to pay you.
Absolutely.
In France.
Absolutely compulsory. And I think the minimum recently is
around 600
euro per month.
In large company, you can, well, it can be more, 1,000.
Yeah.
Well, around 1,000.
Around 1,000 euro per month. That's during the 4th semester. I'm trying to see if we have a lot of questions, I know, and if I don't have time to answer them, I will do my best to answer you later.
There's some questions on scholarships, maybe. Justine.
You have some questions about scholarships. Explain a little about
Limit,
what does
limit of age.
there's no limit of age for the scholarship, as long as I know. The scholarship motivation letter, yes, if I can give you some tips about it. You must know who is a scholarship provider and orientate your scholarship, like what do you want to do with the scholarship, like how do you want to, what's your career project and how that scholarship would help you to achieve your goal. I think that very important that the scholarship provider understand well your goal, your career plan, and when you need a scholarship. Yeah.
There is a question, Justine, on do you accept applications for scholarships even after finishing bachelor's and working for 1 or 2 years? So if you are not many more students and
yes, as soon as you are eligible for the Master of Science, you are eligible for a scholarship.
To be eligible for scholarship, you have first to be admitted in the master program, for sure.
Yeah, that's for sure.
We have a question not related to this presentation, but related to the double degree program, Justine. Maybe.
The double degree program with TUM, 1 year at Munich Technical University and 1 year at ISAE-SUPAERO. This is the same application way like the Master of Science. So you apply through the same website. You just choose a double degree program and you explain in your motivation letter why you want to apply to this program. There is no scholarship provided for this program. However, students can beneficiate from Erasmus scholarship when they go to Germany. And if you want to have more details, you can send us an email, of course. And the double degree program is about systems engineering only. So it's a Master of Science in Aerospace Systems Engineering. Did I forget some question? Are there rocketry related research projects in the master's degree? Rocketry related research projects, like rockets.
we have a professor in launcher.
Okay, launcher. That's part of it.
That's part of it. So
we need a launcher.
We can propose a research project.
I have a question. I am currently finishing a master in physics. Would it be better to apply for a Master of Science or Advanced Master? I think the Advanced Master is more likely to be your eligibility, right? With a Master in Physics. Philip.
Excuse me, I was answering some questions.
With a Master in Physics, they are most likely to apply for an Advanced Master.
Yeah, sure. Yeah. You can do that. We have many advanced master program. I don't want to speak so much about advanced masters here, but you can send an email to info-masters. Maybe we can give the email address. You can show the email. Oh, yes, right. Okay, just send an email. Send us an email with your CV. And we will guide you in which kind of advanced masters you can apply for related to your background.
Justine, there is a question if it's necessary to make a separate application for scholarship. So
yes, for each scholarship they need a motivation letter.
Okay. And so you do it once you have been admitted or at the same time at the application?
Yeah, while they validate their application for the Master of Science online, then the scholarships they are eligible for appear and they can upload their motivation letter directly online. So yeah, as a motivation letter per scholarship. it's before being admitted. Normally when you apply for the scholarship, you finalize your application and then you have the possibility to apply for a scholarship.
At the same time.
Yeah, at the same time.
Right. Okay. And I see a question of, I'm doing a bachelor in electronics and communication.
Yes.
Yes, of course you are eligible, yes.
Yeah, it's right in the topics actually. Welcome to apply. Any more questions? Okay, for the scholarship with ISAE-SUPAERO directly, it's online as well. It's once you apply for the Master of Science, you normally have the possibility to apply for the scholarship. And if you don't see it, it's because you may not be eligible. And if you have doubt, you can write us an email. Okay, so we arrived to the end of this webinar. If you have any questions, copy screen that page, or in any how this webinar will be sent to you afterwards. So you will be able to re-listen to it, revision it. And if you have any more questions, or if we're sorry we did not have the time to take your question, don't hesitate to send us an email, or we will read them again and contact you if we can. So thank you very much for our 3 professors who attended this webinar today. Thank you for their rich presentation, who gave us a good overview of those 3 majors. And thank you who participated in this webinar. I hope you learned interesting things about the Master of Science. And once again, don't hesitate, if you have other questions, to contact us at infomaster@ISAE-SUPAERO.fr.
And thank you, Justine.
You're welcome. My pleasure. Have a good day, everyone,
Bye.
and see you soon.